Hello everyone, welcome to our discussion of Chapter 3. And picking right off from where we left off in Chapter 2, we're going to look at cost, volume, and profit analysis, CVP sometimes referred to, or break-even analysis. The underlying question is, can we make a profit? Is this going to work? We need to be able to see that before we actually happen. So again, this is about trying to predict the future. Since we have an idea of how to know whether a cost is fixed or variable, we know how it's going to behave. We've got categories of costs to be able to track and things like that. Now we're starting to actually ask some questions and get hopefully some answers that will help us to make good decisions. So, using the contribution margin format we learned at the end of Chapter 2. We've separated our costs into fixed and variable. What do we need to sell in order to cover all our costs? Our fixed costs, our variable costs, and what do we need to sell in order to make a certain amount of profit? Because generally we don't want to just cover our costs, we also want to make a profit so we can return that to shareholders as a return on investment. So that is the underlying decisions. So we're going to learn some formulas and things to calculate these in amounts, but we don't want to lose sight of what we're actually trying to figure out. So, first of all, break-even point. The idea is this is where we've sold enough of our product so that we cover both our fixed and variable costs, but have not made any profit yet. So this is the level of sales that will cover our costs. We've sold enough to cover the costs, but no profit. Okay? So, first of all, we need to calculate the contribution margin per unit. Sales price per unit, what I sell my product for on a per unit basis, minus the variable cost per unit. Remember, we keep that constant over the relevant range. So that might be broken down into various variable costs. Might be direct materials, direct labor, variable overhead. But what we're looking at is the difference between the sales price and the variable cost, all of them on a per unit basis. So 1 unit, how much labor does it use, how much variable overhead, how much direct materials, that's your contribution margin per unit. So to calculate your break-even point in units, you take your fixed costs, all of them, product costs, fixed manufacturing overhead, fixed selling costs, fixed administrative costs, we total those up, we divide by the contribution margin per unit we got in step 1. So we divide fixed cost by the contribution margin per unit. That gives us your break-even point in units. Now, you may need to round or things like that because obviously you cannot sell part of a unit. But that'll tell you how many units you have to sell to be able to cover your fixed costs and your variable costs. But it will make zero profit. Now, what if you want to actually make a profit? You want to know how much? Then simply add your target profit to your total fixed costs and then divide by contribution margin per unit. So that tells you how many units need to be sold to make exact amount of the target profit. Again, you're going to round or whatever. The margin of safety, when referred to in your textbook or in other places, is the amount of units sold less the number of units needed to break even. So if your break-even point in units is 500 and you sell 600, then the margin of safety is 100 because you're over the break-even point by 100 units. That's your margin of safety. Now, sometimes if you don't have per unit information, okay, or it may just make more sense to use the contribution margin ratio to calculate break even. So the contribution margin was your sales price minus your variable costs on a per unit basis. contribution margin ratio is the contribution margin per unit divided by the sales price per unit. So you take one more step. It can also be found if you don't have per unit, you just know the totals. The total sales minus the total variable cost divided by the total sales is your contribution margin ratio or percentage. Shouldn't differ either way you calculate it. It should be the same result. You can either do it as a percentage with the percent sign, move the decimal over, or you can just keep it as a ratio, point, whatever the answer is. So your break even or target profit, if you want to calculate it in sales dollars. So we did the break even point in units. This is the break even point in sales dollars. How many dollars of sales, not how many units, but how many dollars of sales you have to sell before you break even. So you could just refer back to your break even point in units times the sales price per unit. And that will tell you your answer. How many sales dollars are you need to break even? You could take your target profit units. If you're doing it, if you've already calculated the number of units you needed to get to your target profit, you just take the answer you got earlier and multiply the sales price per unit. Now, in the case that you can't or choose not to use the per unit information, you can simply take the fixed costs divided by the contribution margin ratio or percentage. If you do that, you will get the sales dollars to break even. You will not get the units to break even. You get the sales dollars to break even. So you use the contribution margin ratio, which, as we found out on the earlier slide, can be calculated using totals instead of per unit. All right, so that gives it a little more flexibility to use in certain situations. And you can take the fixed cost plus the target profit, divide by the contribution margin ratio, and it will tell you the sales dollars needed to reach the target profit. So you got several possibilities of how to get to the same result. Sometimes you may want, if this stuff is going to the boss or you're going to use it to make a presentation, you may want to do it both ways, okay, just to check your math to see you should get the same result. But it may help you to feel like confident in what your result if you did it both ways. So just a quick way to picture this. All right, if you are graphing we did graphs back in chapter 2, this is your revenue, sales, as the units produced and sold go up. Obviously your revenue goes up by the sales price. The costs start at the fixed cost and go up by the variable cost per unit. At a point that they cross each other, that is your break-even point. When profit is 0, when you're down here, your profit is negative, right? You have a loss because you're not covering your costs. Once you pass the break-even point, then you see that the total revenue is going up faster than total cost, and therefore the difference is your profit. So that's a way of visually or graphically representing it. Now, what if you have 2 or more products? Now, this is a little more complicated, but it literally is the same process. You just have to calculate a weighted average contribution margin per unit. So you take the way you do that is you take percentage of sales for product 1. So if you sell product 1 40%, product 2 60%, you take the 40% product 1 multiplied by the contribution margin per unit for that product, and then take the percent of sales, 60% in our example, times the contribution margin per unit for that product, multiply that, and then add them together. Notice the plus sign. That's going to equal your weighted average contribution margin per unit. Then you go back to your regular formula. You take total fixed costs divided by weighted average contribution margin per unit. That tells us our break-even point in units. Back to our original formula. Then if we want to know how much for product 1, we simply then multiply it by the 40%. This is total units. So 40% of those would be product 1, 60% would be product 2. And that would tell us how many we would sell of each product. So we can, look to the budget and things like that going forward. So that is how you do it with two products. You have to average them together and then apply the formula. Same thing with the target profit. You would add the target profit to your fixed costs. You divide by the weighted average contribution margin per unit. Total sales in units to reach the target profit. All right. You can then multiply for each the 40%, 60% to see how many sales of each product to reach your target profit. Now, the idea that you don't just do this once. You don't just calculate your break-even point and you're done. You use this to look at various scenarios. You change a variable. Say, okay, what if my variable costs change by this much? What if my fixed costs change by this much? What if my sales price went up by 10%? Where are those going to change? Well, it could change our contribution margin. If you change your sales price or variable cost, it will affect the contribution margin, which we use throughout our calculations. Fixed costs, new equipment or advertising could change that, and that's in our formula. Change the factors, recalculate break-even point, recalculate target profit units or dollars or whatever to see what the impact is. Does it make our break-even point go up? Does it make it go down from what our original scenario was? And then note the change. Okay? So you might run 5 or 6 different scenarios and look at how they compare. What happens to break-even point? All right? What happens to how many sales you have to do to reach a certain profit? Now, concept that we want to throw out there to you remember is the idea of leverage. It's used a lot when describing a firm and how its mix of fixed and variable costs. If you have high fixed costs relative to variable costs, it's referred to as leverage, or you're a leverage firm. All right? So in those cases, it's going to take a lot of volume to reach break-even point because you have a lot of fixed costs. But after break-even point, your profits rise very quickly. But on the other side, it's more risky. Falling below break-even point can have large losses. So if you have the risk of getting a lot of profit, you also have the risk of getting a lot of losses. You have to get to break-even point. It's harder to because it's a higher break point at which you break even. But it's very profitable once you get break-even point. That's what leverage does for you. Think of it as you're sitting close to the seesaw at the park or at the very end. Leverage is at the end. You go way high and go way low. Sit close to the middle and you don't go up and down as much. That's low leverage or high variable cost relative to fixed costs. You reach break-even quickly. After break-even points, you don't have as much of a profit. So you don't have as much upside and you don't have as much downside. High leverage equals high risk and reward. Low leverage equals low risk and low reward. Risk and reward tend to go together. So, contribution margin and the resource constraint. When we have done this kind of analysis, and we've done a lot of looking at contribution margin, another decision that we might want to look at, especially when we're making more than one product, typically you would want to make those products that have high contribution margins per unit or high contribution margin ratios. Right? I mean, that seems to make sense. That would be logical. Is if one product makes you $4 and the other product makes you $5, you would prefer the one that makes you $5. And we're talking about contribution margin per unit, sales price minus variable costs. But what if they use the same resource? What if we're choosing between that and they both have to go and be used by the same, be worked on by the same machine? Now we're talking about using the one that has the highest contribution margin per unit of scarce resource. So if everything has to be done on this machine, then you want the one that's going to make the most contribution margin per hour of machine time. So example, product A has contribution margin of $10, it uses 2 hours. And product B has contribution margin of 7, but only uses 1 hour. So if you're just looking at 7 and 10, you might choose product A. But because product B contributes $7 per hour, while A contributes $10 per hour, we're actually better off, more profitable, if we use B on that machine or make B on that machine rather than A. So it doesn't mean we'll just stop making A, but if we are choosing to emphasize one or the other, we might choose B in this case. Now, concept in your textbook about variable costing as an internal decision tool. This is really taking the whole concept of contribution margin format to the extra step. Okay? It basically says fixed product costs, because they are fixed, can't really be controlled. So we're going to move them and treat them as period costs. Now, we know in the back of our head that that is not acceptable for GAAP. They have to be product costs. They have to be through inventory. But for decision-making purposes, often firms will move those costs out of their decision-making process because they are not controllable. And if that's the case, when you make more than you sell of these, your fixed products cost will be in inventory, and thus GAAP will have a higher profit than variable costing. So you'll actually have a difference between your contribution margin format income statement and your regular income statement. When you sell more than you make, your fixed product costs are moved from inventory to cost of goods sold, so that variable costing will have a higher profit, all right, than GAAP. So there's a difference there, and it's just literally moving, when you look at it, rather than costs that would typically go into inventory and into cost of goods sold, just get moved to period for our analysis purposes, not for financial reporting outside, but internally.